This is going to be hooked to your door of your mailbox. When the door is opened, closes the signal, simulating that the button's been pushed, sends a signal to the doorbell receiver. The receiver picks up and sends a signal to the ESP32, which sends you an email on your phone or device. You've got mail. Open it up. Your mailbox was opened at such and such a time. Okay, so I chose to use the ESP32 C6 just because of the small form factor. It takes 5 volts or 3 volts. And yeah, I had a couple of them laying around. So inside the box, you've got the receiver, and you got the transmitter. And it comes with a little key to open the transmitter to change the batteries. It uses a coin cell, CR2032. And so we're going to go over the basics of this, how it's installed. So simple on this particular model. The advantage to these is the size. So they have enough room to put a little ESP32 in it. And this one also is relatively easy to hack. There was some other ones that I got on Amazon, on AliExpress. I can find it. I thought I had it. Oh, here we go. Yeah, I had it on. I had bought one off AliExpress just to see it looked similar. And this thing, you can see, is way smaller, and the transmitter is even smaller. You know, kind of look to be the same, but there's no, I didn't open this up, but there's really probably no way to get an ESP32 in there. You possibly could. I haven't tried, but it's definitely a lot smaller form factor. So I haven't played with this one. So that's something to keep an eye on. If you can't find this exact one, keep that in mind. It's smaller sometimes isn't better when you're trying to hack some stuff, because we know stock is boring. So basically in this model, you got 2 screws. Open it up. This is actually my testing model, so I've got some additional wiring done with it, and comes apart pretty easy. The little speaker goes right here, and you can easily remove it. In my application, I didn't really need the speaker, so it's gone. This small C6 actually fits right in the compartment. So what we're looking to do is get a signal from the receiver to use to key the ESP32 that it has a signal and send an email. And so an easy way to do that is to tap off the LEDs. This has, I want to say, like 5 LEDs around it that light it up, and it flashes when when it receives a call, and it also plays a tone. One of the things that I will mention that caused me a lot of time is the fact that when you change the tones, so on this model, you change these to up and down, it'll run through a different ringtones. Those ringtones could and do have different amounts of flashes of the light. So depending on how long the ringtone is, it might be 5 flashes, it might be 7 or 8 flashes, something like that. Just depends on how long the ringtone is, and I did not realize that when I was testing it. The first couple tones that I did all seemed to be the same, around 5 flashes. So I spent a lot of time programming this to read a train of 5 flashes or 5 signal drops. And so keep that in mind when you're doing this. If you happen to change the thing, which I did have a speaker in, I didn't realize that it was flashing more than 5 times, and so I wasn't getting a signal sent. So on this particular model, so there's a small transistor that's right here, and you need to tap off one of the legs of that transistor, and it is booger to try to solder. You need a real small tip, and you need some magnifiers, and that's the worst part of the job. I'm possibly there's other places that you could find, but in my application, that's what I chose. I did try the other side. I don't remember what port of the transistor that is, but it wasn't quite as clear of a signal, so this side was better. And in order to test some of this stuff, I ended up using what's called a logic probe. So if you don't know, logic probe is used to find out whether a circuit is sensing a high or a low. So either it's getting a ground or, in this case, 5 volts. And it'll do it really quickly. It gives you a tone instead of looking at a multimeter. So it was kind of hard with the multimeter because when that light's flashing, it's kind of quick. So it's hard to read, even with a digital multimeter, whether it was getting a good signal or not, but a logic probe would help. So if you're doing this kind of stuff, you might want to invest in something like that. It works really well. And it does, like I said, 5 volts and 3 volts code, or voltage, sorry. So anyhow, back to the thing. Like I said, I've got additional wiring on here because I wanted to hook up some different signals and monitor things when I was testing. One of the other things is this board does not have any reverse flow. Obviously, you're putting voltage back into this board where it's not designed to have being backfed. So there is no reverse current security on it. There is on the ESP32. So what I ended up doing by mistake was plugging it into the wall, and also had my USB plugged in at the time, and I blew out the inductor that's right here labeled 102. Got a little pinhole in it. So I cautiously added a diode in the positive lead, so that potentially won't happen again. But there's really no need to, there is no need to plug in both this and this at the same time. If you're doing testing, you can just plug in the ESP32 and it will actually power the low voltage portion of this board. And the doorbell will go off and send you an email just like it normally would. It's just that you're providing power this way versus the doorbell providing the power. And then what I did was cover up the high voltage area with some black tape on the model that I'm actually using. And then you can stick this right in there, maybe put a piece of foam or something just to hold it in place while you cover up and put the cover back on. And that part's good to go. In the code, it will show you the LED will flash the number of trains it receives, the count. So we're going to plug it in. So hopefully you can see. Let's do a little shield here, the LED. So we have a red LED on right now. Try to bring this up to the camera. Okay, so I'm going to go ahead and activate the thing. When I activate it, the lights on the receiver are going to flash, and then when it counts it, then it will flash that count. So that will help you identify if you have the tone set to the correct range between 6 to 8 or 4 to 7, whatever it is you set. You can customize it also. So we're going to go ahead and ring the doorbell. Let's see, it's ringing, and now the LED should flash the count. 1, 2, 3, 4, 5. Right? So that will help you troubleshoot, that make sure that you've got the correct tone set within that range. On the transmitter side, so we're using a micro switch. Make sure it's a weatherproof micro switch because it's going to be outdoors. There's some of these, they come with both normally open, normally closed side. So you've got a basically like a center wire. I think this one might be the ground. And you have one that's normally opened, and then you have one that's normally closed, depending on which application you have to do. So you need to figure that one out. And then I'll put a little illustration here, and we'll talk about how you can align that on the door with a picture. On the transmitter, so there's two options. You can bypass the switch, so you'd use this side is separate from this side, so the switch basically closes the left contacts and the right contacts when it's pushed. That's what it normally, it's a normally open switch, and it's using the logic probe and whatever. I was able to figure out that this is it's giving a ground, so it's drawing it low. And that's how the switch is operated. So basically the micro switch is bypassing this switch when it is open. So the door is closed right now. Now the door is open. It's going to be closed, sending a switch to to bypass this, providing this with ground, which is going to fire off the transmitter, and the receiver will see it. And then what I did is use the wire, these little cutouts. So in this board, there's a couple cutouts. I used those to snake the wires through, like so. Okay. And then this little piece of silicone goes over like this, right? These little wires sticking out. And then the piece of silicone had a cutout for the antenna, and you just do the same thing with these two wires. You could place them apart. I used some hot glue or sticky tape to hold these wires in place like this on the board when you're taking it apart to change the battery or installing it. You need to have it some way so that it's in place, and then that's going to go back in just like so. You want to make sure that those wires are going through the little cuts that you made just on that one lip, just like the antenna. Okay, and then these pieces pushed together are going to close it and seal it. And then there is, if I match these up, there's a little wall, and then there's the latch. And so basically you just run the wires around the little wall and out the hole, just like that. When it's closed, and I'll show you it's closed. It actually works really, really well. Now you can see they're not being pinched, right? And then just like that, and they're in there and they're not pinched. Now I also, the little tool that they gave you, I modified it so that there is room for the wires to go in, because otherwise, if it's not modified, there's, that tool is built the whole way. So cut your little notch so that the wires, and then you can pop that thing back open if you need to work on it or change the battery. Easy peasy. I think that's like awesome that they allowed you to modify this thing such an easy way and keep it weatherproof. Okay, so looking at the mailbox here, we're upside down. Here is the door of the mailbox. And so before I removed it from the post, I marked out where the pad that it attaches to sits. So basically everything from here, all this area is open space that I can use to mount things to. It's not attached to the pole. Hopefully you have the same kind of situation. You can see from this is the close-up of the switch. We just used a
3M VB very high bond tape, the double-sided sticky tape, to attach it in the housing. And what I did was kind of adjust it so that when the arm is extended, basically the door is open, the little arm is just right up against to this piece of metal, so it's not over it or contacting it. And then I ended up having to shim it so that it will close and activate the switch when the door is closed. So this is just a little 3D printed shim that I made. You could use anything around that's not going to be affected by weather. And it is, I think I might have siliconed that in with some shoe glue or some kind of contact adhesive, or you could just use the same double-sided tape. It probably worked just fine. And anyhow, so that's the adjust. Super simple to adjust it, and then run your wires. And I end up, I think, putting some electrical tape or some other kind of tape that would handle outdoors, just to keep the wires secured so they weren't flopping around. And you can only, like, when the door is open, all you see is this little piece of metal sticking out. It's really, nobody knows it's there, honestly. We are now in the Arduino IDE. We've got the ESP Mailbox loaded up, and here's the libraries you're going to need to include. Google how to get them if you don't have them. These are the credentials that you're going to have to change for your Wi-Fi to work. The Wi-Fi SSID is the name of your Wi-Fi. My home Wi-Fi, that's what it's called, so that's what you would put there. This is the password for your home Wi-Fi, whatever it is, that's allowing this to connect to the internet. This is your email provider. So if it's Google, Gmail. If it's AOL, it's AOL. This example is Google. So I don't know any other providers. You're going to have to get information yourself. So this is your email author who is generating this email. That would be you. So your email address. This is the recipient who you are sending the email to. So if you wanted to send it to multiple people, you would put a comma between those. I think that will work. Honestly, I don't know for sure, but that's what I would try if I wanted to do multiples. But that's where the email is going. This author's password is a 16-digit password that Google uses to help people or help applications to authorize them, basically. So if you have two-step verification enabled, Google is looking for a way to verify that you are a legitimate user, and so that's what that key is. If you type into Google 16-digit app password, you should be able to figure a way, and they'll provide you one. You just have to verify your credentials and who you are through your Google account. And that password you can use on multiple applications that are sending email, in these like ESP32, Internet of Things devices. This next line is the input pin that the ESP32 is using. It's the one that it's listening to, and this is the LED pin output on that board, which in mine is the ESP32C6. So that's where the LED light for blinking is. The other thing that you might want to look at is the pulse count. So like I had said earlier, the the different tones, some of them have different counts, different amounts of LED flashes. So a longer tone will have more light flashes. I didn't realize that. I was stumped for hours trying to troubleshoot this whole thing. When I first turned it on, I noticed it was counting like 5 times, and that worked for quite a long time. And then all of a sudden, something was changed when I was troubleshooting, and it wasn't working. We did a lot of troubleshooting to try to figure out what was going on. And so in this code, there is an LED that's going to flash how many pulses that train counts. So it will help you troubleshoot it, basically. That's the illustration I showed when I was demonstrating the ESP32 actually receiving and transmitting the email. So that's where you change it. You could change it to 1 to 35 if you wanted to. I was just trying to kind of be a specific band of numbers of counts, just to keep it accurate. But it's really not super important. That's just the path that I chose to. So anyhow, those are some of the things that you're going to have to change in that. And that's it.